I'm Titus Murphy. I'll be presenting on my capstone of domain incremental machine learning, which is very technical, and then the topics of the early church, which is far less technical. And Dr. Tate was my supervisor through it, and so thank you for that. Thank you all for coming and attending. This quote by John Chrysostom sort of describes my capstone, and he's talking about 2 Corinthians 3, and he says, "To the glory of God through us." What is to his glory through us? God fulfills his promises by us, that is, and by his benefits towards us to his glory. For this is for the glory of God. And I really like that by his benefits towards us is how he fulfills his promises for his glory. I do hope that this capstone pushes to God's glory. A brief outline of what we'll be looking at. I'll be introducing some of the background to my work, how I chose it. I'll be giving a crash course in machine learning in about 3 minutes. I will be then talking about the first part of it, which was 6 credits at National Science Foundation research experience for undergraduates last summer, and then I'll move into talking about the early church and church writings and what sort of work I was doing there, and then some concluding thoughts and time for questions. So this is what we call a word cloud, and the size of the word indicates its importance or similar, and it's a word cloud of my interests, actually. You can see they are rather diverse and broad and kind of tough to tie into one nice little capstone. And so I was interested in graduate school, and I talked to a professor from Colorado College who said, "Oh yeah, if you're interested in graduate school, you should do research." And he pointed me to NSF REUs. And I applied basically at the deadline and got in. And then somebody else put a paper called Top2Vec on my radar, and it basically is about using machine learning to find out what a paper or collection of documents is about. And I was like, whoa, can we do this to the early church? And so I was like, a capstone. And so I proposed that. And then just a few weeks later, I see a random poster on the bulletin board just in the hallway back there, and it said, "Do you love the early church and computer science?" And I was like, yes, I do. And it was a poster for church writings, and so I reached out, and they were very kind and gave me access to all their data. So that saved me a lot of work finding data for my capstone. Sattler equipped me through quite a few different things. First, through the computer science classes, obviously, under Dr. Tate and Professor Murphy. The History of Early Christian Theology class was super inspiring just to read those texts and get a feel for what is being talked about. I was also really inspired by Kevin Cron's capstone on natural language processing a few years ago. It is worth a watch. It is more technical than I'll probably be, but I was just seeing what he did, and I was like, whoa, if that's what you can do, then surely I can do something, a smaller version of that sometime. I was also interested in history by Dr. Lehman, and spiritually inspired by Professor Anderson towards all this work. And so now, the crash course on machine learning. Here we go. In what we might call classical programming, you take some data, some input, you take some rules, and you get some output. For example, we might write a function that checks if it's raining outside, and takes in does the sensor say it's raining? Well, if the sensor says it's raining, then it's raining outside. So we say true or false otherwise. But then with machine learning, we can actually predict whether it's raining outside based on something like the barometric pressure. And the computer itself learns these relationships with some degree of accuracy. We don't say if the pressure is below 29.92 inches of mercury, then it's raining or it will rain. We say, here's a bunch of data. Here's a label for this data, whether it rained or not. And we say, please figure out what the mathematical relationship is between this data and whether it's raining. And the computer figures it out and goes, all right, so I can predict with some percentage of accuracy that it's raining. And then a subfield of that is natural language processing, which deals with human natural speech, the way we normally talk. And it makes it accessible to computers, which are inherently mathematical machines, and math does not do very well with words. We mathematicians tend to panic, in fact, when they start seeing words. And so what natural language processing does is it takes these words, it might be a single word, it might be a paragraph, it might be a sentence, it might be a whole document, and it turns it into a series of numbers. And these numbers encode useful information such as what is this document about, what is its relationship to other documents. And some of that is important for my capstone. And for more of this, you can review Kevin Cron's capstone video where he spends a lot of time describing exactly how it works, but suffice to say, it does work. So on to what I actually did. This was during the summer of 2025. We wrote a paper for our work, and we titled it Mitigating Catastrophic Forgetting Using Improved Clustering-Based Episodic Memory. And we created strata models, as we call them. And, well, I warned you that this might be technical. Basically, the field was working with online models, which means that the data is coming in a continuous stream. So think of a robot exploring a room or a series of rooms. And you can see that the robot's constantly getting these pictures coming in, and it needs to figure out what to do next, versus what you might call a pond, where all the data is pre-collected and it just has to process it. There's also domain incremental, which means that each room is inherently similar to the next room, but they're not the same. The model has to figure out how to do each room separately, individually. But they are related, so it should also learn relationships that will help it to process each room faster. The problem that we're addressing is when, in our scenario, a model learns a new task, but then it forgets about those older tasks. So say it's exploring several rooms, it goes through room A, figures out what to do, goes to room B, figures out what to do, but then forgets about room A because it's learned what to do in room B. And basically what we did was we used episodic memory, which is just a few samples, maybe a few pictures from that old room, and saved it to avoid forgetting on those tasks. But the problem here, again, is that we don't know exactly when the new task starts. The robot does not know when it enters the next room. It can somewhat guess, but it doesn't actually know. And so we use a grouping mechanism called clustering that puts similar samples together, and it would, because similar samples tended to come from similar tasks, that would allow it to move forward and still remember old tasks. And we also applied our framework to a doer machine learning model to further increase that performance. So a bit of background here. NSF is the National Science Foundation. They fund these research experiences for undergraduates so that students who want to go to graduate school can experience research. And they're offered all over. Mine was at Salisbury University under Dr. Annie Liu. And it's 10 weeks. I did around 400 hours of work there are 11 people in our group, but only 3 in the 3 co-researchers. And it was fully funded, including room and board, which was quite nice. So the technical details, I'm actually not going to walk through all of this. If you want them, you can take a picture. Some important notes, though, are the 3 data sets we use to test our model are very commonly known. If you talk to a basic and machine learning researcher, they should be able to recognize and talk about these data sets. And basically, the variations of task types we used involve things like rotating. So MNIST in particular is numbers. And one of the things we had the model do was, can it recognize a 1 when it's straight, when it's normal? Can it recognize a 1 when it's horizontal? Can it recognize a 1 when it's rotated to some angle? And can it still recognize those original numbers as well? So here's some charts showing how our model did. And our models are called strata, as I mentioned earlier. They're purple and orange. If you can see that, they are along the top there and the bottom here. And the first one is showing how accurate does it still do on that first task. So how accurate does it do on a normal number when it's seen a bunch of different rotated numbers. The second one is showing how much does it forget about past tasks. So how much does it stop remembering how to do a normal number when it's seen, an upside down version of it. And then there's another chart where, again, you can see that we got really good results across the board, and often, or almost always, had the good number, with some exceptions that we detail in the paper. So deliverables for this first part, technical research paper that we published at a workshop, IEEE workshop at IDCM, which is International Conference on Data Mining, back in October, I believe. And it's available online. We also made a poster and presented it at the RU itself, and our code is open source on GitHub. So, part 2, the early church. Church writings topical concordance. So the problem here is that there is a dictionary concordance on the site, but it's not very big. It's only got around 25 entries per topic. As you can see, there's a few topics listed on the screen. And it's also made deductively. Somebody was like, all right, what might people be interested in from the early church? And just curated a whole list of topics and then just searched the early church for those topics. And so my project was basically making something that solves both of those. One, have a lot more, because machine learning allows us to do data collection at scale. And then 2, create these topics inductively. So go to the data and ask, what does this contain? What did the early church talk about? And then use those as our topics. A bit of background, Church Writings is a group of researchers right here in Boston. And they have a bunch of different works. They have all the way from Clement of Rome up to Augustine. And this is just a chart showing the timeline of when those works are approximately thought to have happened. And they generously allowed me to work with all of their stuff and to process it using machine learning. So huge thank you to them, Tom Kruger and Max Secor. And Stephen Taylor actually works with them as well. They're fantastic people. This saved me so much work. If you've talked to any data scientists, they will say that data collection and processing and cleaning is like, I think they say like 60 to 70% of the work. I got it handed to me on a silver platter. So yeah, I cannot thank them enough. So now a non-technical version of what I did. Basically, I took all of their texts, I chomped it into pieces at the paragraph level, and each one of those texts you call a document. And then I used this machine learning technique called semantic topical clustering to create an inductive list of topics. So basically it would go, here's all the documents, which ones are related to each other, and they would group related ones or put them near each other in space. And they would say, all right, here's a big collection of documents. What are all these documents about? And they would figure out some top keywords to use for those documents. And I would then take those keywords and basically turn it into some, what I call a header word, which is 1 to 3 words describing what exactly that collection is about. But the problem here is that if that's all you do, if a document has more than one topic, it will never appear twice because they can only ever be in one collection. So I actually did semantic search then on the corpus for those topics and used that as the output for my capstone. Again, technical details, use bird topic. I'm not going to talk about most of this. The success metric was rather interesting. A big part of this project was trying to figure out what works and what doesn't work, because it is really hard to tell when a project like this actually does well, because computers can't go, okay, this is an accuracy score or something like that. If I get something called MPMI coherence and a topic of 0.5 and a topic diversity of 0.75, I may know what that means, and I may be able to tell you that those are good, but that doesn't inherently fix the problem that if my model says that Jesus feeding the 5,000 is related to priesthood, we have a problem. So I just had a very cheap LLM, large language model, ChatGPT for those who don't know, judge its accuracy. It got a score and give back a score between -1 and 1. -1 meaning this is absolutely off topic and terrible. 1 meaning this is exactly what a human would think should go in this section. And then I tried to, of course, get that score as high as possible. This project is sort of incomplete. So as with all computer science projects by and large. So some things I want to do is actually add back some of those deductive topics, because people are interested in things beyond just what they most talked about. They're interested in, topics that we would impose on them. So I want to add a few of those in and then have them also show their topics. I want to get my work hosted on their live site, which I generated a file that basically will drop in. It's going to take absolutely no work for them. It just hasn't happened yet because I want to do that first part first. I also want to build on my work and create an improved semantic search for the website. If you currently search on a website, it's primarily text matching, so it's not actually very good searching. But with this baseline, I can actually build a much better model and then potentially publish a technical paper on what I did, especially the evaluation metrics. The deliverables I had were a processing pipeline, as we might call it, going from a corpus to a concordance, and it, again, generates that drop-in replacement. I created quite a few different evaluation metrics. The one I think was coolest was the scale that LMM used. I also have all of their data now pre-processed and cached and chunked, and all of that work needs to be done for machine learning, so I could potentially hand it off to future researchers to do more work on it. I also have quite a few visualizations of the data. I didn't share very many of them, but I do have them. I'll show you one in a slide, and laid the groundwork for a future analysis if somebody wants to do that. So what did Yearly Church talk about? Well, you can see they talked about a lot of things. This is actually just a quick, probably 15-minute project, side project, of which there were many. Basically, it would count up which words appear most, and then it would ignore suffixes. So like God and gods, it would have to treat the same, just because man and men, if it kept counting both of those, it would dilute the word cloud significantly. But I was impressed that God and man and one ended up as some of the top 3 words. And indeed, that's what I find with my concordance as well, is that those topics are very central, and any topic relating to them tends to have more documents. The impact is rather broad, I think. For personal stuff, I was able to do research before entering graduate school, which is really, really helpful. I was able to publish a paper along with some co-authors, made quite a few connections there. I got to experience academia outside of Sattler and see what that's like, see how people think, see what their standards are. That was very interesting to see. And this whole connection to church writings, I'm going to keep working with them, going to be able to do more machine learning, some of which I described. And it also helped me clarify what exactly I wanted to do for graduate school, which areas of research I'm more interested in versus less. And in terms of kingdom impact, I'm hoping my project makes the early church just a tiny bit more accessible for, I said, scholars, pastors, and citizens. All of them are important, but basically giving you a starting point for further research. If you are curious, why does this appear so often, perhaps you'll go on church writings later today and find out yourself. And indeed, that's the second point of my kingdom impact. I'm hoping that this inspires you to go on and find out exactly what the early church talked about.